Okay, for video homework number 2, question 1A says state the ratio test. So for the ratio test, let the sum from n equals 1 to infinity of a of n be a series with non-zero terms. And let p equal the limit as n goes to infinity of a of n plus 1, the absolute value of a of n plus 1 over a of n. And we have 3 outcomes from this test. 1, if 0 is less than or equal to p, which is less than 1, the sum of n equals 1 to infinity of a of n converges absolutely. 2, if p is less than 1 or p equals infinity, the sum from n equals 1 to infinity of a of n diverges. And 3, if p equals 1, the test provides no information. Question B says state the alternating series test. So for the alternating series test, suppose we have a series, the sum n equals 1 to infinity of a of n, and either a of n equals -1 to the n b of n, or a of n equals -1 to the n plus 1 b of n, where b of n is greater than or equal to 0 for all n. Then, if 1, the limit as n goes to infinity of b of n equals 0, and 2, b of n is a decreasing sequence, then the series sum n equals 1 to infinity of a of n is convergent. Okay, now for 2a, give an example of an absolute convergent series where the ratio test does not apply. So, ratio test doesn't apply when, as stated above, p equals the limit as n goes to infinity of the absolute value of a of n plus 1 over a of n, when that equals 1. So, the sum of n equals 1 to infinity of 1 over n squared is an absolutely convergent series. And if you take the limit, p equals the limit as n goes to infinity of, don't have to do absolute value because there's no negative numbers, 1 over n plus 1 squared times n squared over 1. Taking the leading terms, that would be n squared over n squared, which would equal 1. So based on this, it is absolutely convergent and the ratio test does not apply. Okay, and for 2b, for which values is the series? So we want the series, the sum from I equals 0 to infinity of -1 to the I minus 1 x to the I over 3 to the I minus 1. We want to find when is convergent. When does it converge? So we're going to do the ratio test. So P equals the limit as I goes to infinity of the absolute value of -1 to the I plus 1, which is just I, times x to the I plus 1 over 3 to the I minus 1 plus 1, which is 3 to the I, times the absolute value of 3 to the I minus 1 over -1 to the I minus 1 times x to the I times x to the I. And we can cancel out the negative terms due to the absolute value, and then we get P equals the limit as I goes to infinity, and we group the terms. So we do x to the I plus 1 over x to the I, the absolute value of that, times the absolute value of 3 to the I minus 1 over 3 to the I. And when you subtract the exponents from each other, you would end up getting the absolute value of x over 3. And so this series converges when -1 is less than the absolute value of x over 3, which is less than 1. And to get the 3 out, you multiply both sides by 3, so -3 is less than x, which is less than +3. And then you check the boundaries, and at x equals 3, the sum from I equals 0 to infinity of -1 to the I minus 1, 3 to the I over 3 to the I minus 1 diverges based on alternating series test, and at x equals -3, the sum I equals 0 to infinity of -1 to the I minus 1, -3 to the I over 3 to the I minus 1 also diverges based on alt series test. So for what values of x is convergent, so the radius of convergence is from, the interval of convergence is from -3 to x to +3.